Parametric equations have many applications to real life. Let's take a look at an example of shooting a basketball.
You can go. Oh, wow.
So in the video, the distance from the free throw line to the basket is 15 feet. The height of the hoop is 10 feet. But the initial starting position of the ball is roughly 4 feet. So the ball travels up into the basket in roughly 1.3 seconds. So in order to solve the parametric equations, we need to use the general formulas for the position, velocity, and acceleration vectors, which are these equations right here. The position is measured in feet, velocity is measured in feet per second, and acceleration is measured in feet per second squared. So when the ball is in my hand, it's at a time of 0, and when it enters the hoop, it's at roughly 1.3 seconds. The position where the ball starts at is 0 with the height of 4, and then it travels 15 feet after 1.3 seconds to a height of 10. So in order to find to solve for the variables here, we have to solve them basically. So what you would do so this would be the x of t value, this is the y of t value. So using those in the position, so the x of t is c1t plus c3. And the y of t would be negative 16t squared plus c2t plus c4. So using these vectors, or the vector at a time of 1.3, you know that the x of 1.3 value is going to be 15, and then the y of 1.3 value is going to be 10. So you can set, or since you want this to be the x of 1.3 and this to be the y of 1.3, so you can put the 15 here and the 10 here. And this value is going to be the C3 value, and this is going to be the C4 value. So you can plug that in. So this one is just going to be C1T. Plug the T in, so it's C1 times 1.3. This one is going to be 1.3 squared plus C2 times 1.3 plus 4. So solving for C1, you have to isolate the C1 first, and then you would get 11.538 equals C1. And then for the y value, isolating everything, you would get 25.415 equals C2. Writing all the C values that we have out, C1 equals 11.538, C2 equals 25.415, which are the x and y are solved from these equations, and then C3 is given, or it's in the position vector. C4 is 4. So plugging those back into the general formula here, we get these as our position vector, velocity vector, and acceleration vector. So the first thing we're going to try and find using these is there's a tangent line to the curve at t equals 0. So to solve that, you would use the dx dt, which is this value, and then the dy dt, which is this value. And since we're finding it at t equals 0, we can substitute 0 for all the t values. So this would become negative 32t plus 25.415 over 11.538. When you substitute t in, which is 0, you get 25.415 over 11.538, which is 2.203. So what you need to do next is find the x value at t equals 0 and then the y value when t equals 0. So you plug those in and then you plug 0 in for the time. You get x equals 0 and then y equals 4. So to find the tangent line, it would be y minus 4 equals 2.203 times x minus 0. So the next thing that we're going to try and solve is speed and direction of the ball at t equals 0. So this is the general equation to find speed. So using the velocity vector, the general formula for finding speed is 11.538, or is radical 11.538 squared plus negative 32t plus 25415 squared. So the speed at t equals 0 is going to be radical 11.538 squared plus 25.415 squared, which ends up becoming 27.911 feet per second. So to find the direction of the ball, this is the general formula, and using the general vector, you get again it's at t equals 0. So when t equals 0, y prime of 0 is 25.415, and then x is 11.538. When you plug that into the calculator, you get the direction is 1.145 radians. So the last thing we're going to find today is the total distance traveled. So this is total distance equation, and again using the velocity vector, you would plug it in for the dx dt value and the dy dt value. So this a is the starting time. So in this instance it's 0, and then b is the ending time, which in this instance is 1.3. So 1.3, or the integral of from 0 to 1.3 of 11.538 squared plus negative 32t plus 25.415 squared. When you solve it, it becomes 21.665 feet. And there's parametric in a real life situation.